Last time we watched a chip carry a 1. No translation. The full adder did it, 3 inputs, 2 outputs, 4 cases. But those gates weren't invented for arithmetic. The names give it away. And, or, not. Nobody names an arithmetic part after a conjunction. They came from bool, an algebra not for numbers, but truth. So the gates are logic, wired up. And logic you speak fluently. You've been using and since you could talk. Both things hold. Not flips it, and or wants at least one. You know these. The truth table is bookkeeping, a grid recording what the word already told you. 4 rows for and, 2 for not. You could have written them yourself, which leaves me stuck. If you already know the word, why a table? Back up. Before we connect statements, we should say what one is. A statement describes a state that can be decided, unambiguously, true or false. Read that again and notice what it doesn't say. It doesn't say true. Take 1. Every prime number greater than 2 is odd. True, an even number over 2 is divisible by 2, not prime. Now another. Every continuous function is differentiable at every point. A statement. This one's false, and the absolute value function is y. You can draw it without lifting the pen. At 0, a corner. Which slope goes there? The one coming down or going up? Neither. False is fine. A perfectly good truth value and still a statement. Third one, and you tell me. This painting is beautiful. That one's out not because we don't know, but because nothing decides. Boole worked in Britain and Ireland in the 1800s. He didn't want a machine. He wanted to know whether an argument is valid by shape. Think what that claims. Swap every noun in a good argument, still good. Mathematics runs on that. You start from axioms, true statements taken without proof. Then you derive theorems. Axioms plus derived theorems, that's a mathematical theory. Deriving is the interesting bit, and Boole thought it should be mechanical. So he wrote an algebra whose variables take 2 values. True or false? Strange thing to write, though. Algebra is where you add and multiply. So what are the operations here if your sentences aren't numbers? You need one more piece of machinery, an expression with holes. A statement form is an expression with placeholders, x, y, for statements. Fill the holes, you get a statement. Substitute sentences, or true and false. Take this one with me, x and a or x. For x, put 3 is less than 8. True. For a 9 is prime. 9 is 3 times 3, so false. Inside the brackets, false or true. One of them is true, so true. Now x and that. True and true. The whole form comes out true. We never used what those sentences said, only whether they were true. Nearly a century after Boole, a graduate student works on a room-sized calculator. Its control circuits were relays, electromechanical switches, clicking. His name was Claude Shannon, and the problem in front of him was ugly. Relay circuits came from intuition. You wired what seemed right, then tested. Shannon recognized the algebra, and, independently, others did too. Boole, dead 70 years, with nothing to run on. Now you could put a circuit on paper and calculate it before soldering. That worked only because the connectives were pinned down. So what pins them? Not the English. The sentences dropped out, their content never entered. What pins a connective down is its truth table, and nothing else. Negation. Z equals not x. 2 rows, since x has 2 values. True to false, false to true. That's the not gate and the whole definition. No further fact hiding. Conjunction. Z equals x1 and x2. 2 inputs, 4 rows. False, false. False, true. True, false. True, true. Only Only the last gives true. The other 3 false. That's the AND gate. Disjunction gets 4 rows, and 1 is where English disagrees with itself. Someone offers you coffee or tea. Say both and you're making a joke. Nobody had to explain that to you. The offer was one or the other. Now a different sentence. Applicants need a degree or 5 years experience. You've got both. Are you disqualified? Obviously not. Same word, 2 operations, and you switched between them without noticing. That's not sloppiness. It's in the language, a problem if the word defines. Then the connective would be ambiguous too, and asked about coffee, you're stuck. It never has been ambiguous. The table does the defining. The word is a label stuck on, which raises the question. 2 meanings, 1 word, which did mathematics keep? Both. It kept both and gave them separate names. Disjunction first. Z equals x1 OR x2. 4 rows again. False false gives false, nothing true in, nothing out. False true gives true. True false gives true. Now true true. Both of them. This row also gives true. The inclusive reading, your job advert. Having both doesn't disqualify you. Now the other. Antivalence or exclusive or not, x1 is equivalent to x2. It's true exactly when your 2 inputs disagree. False false false, they agree. False true true. True false true. True true gives false. Both isn't an answer to coffee or tea. Put the 2 tables side by side. Rows 1, 2, 3, same. Row 4 is where they part, the whole content of exclusive. The XOR gate, and you've seen its table before in costume. Last episode, adding 1 and 1 in binary. Sum 0, carry 1. 1 and 1, 0. 1 and 0, 1. 0 and 0, 0. So which of the 2 did the adder's sum output implement? You've got it. The exclusive one. 4 rows matching to the last case. Be careful what that means, though, because the tempting reading is backwards. The tempting reading, engineers built a circuit imitating logic. Your reasoning in metal. But Shannon didn't build an analogy. He noticed an identity. 1 specification, 4 rows realized twice, in sentences in switches. Neither is the original. The table lives in neither wire nor English. There's one real difference worth holding on to. A circuit takes time. Signals arrive late. Gates have delay. A Boolean function doesn't happen, it is. One more distinction. Everything we've drawn depends only on its inputs. Always. Some circuits don't work like that. The output depends on current state. So it has to remember, and where would you put what it remembers? Nothing in that chip is imitating your reasoning. It obeys 4 rows. Nothing in that chip is imitating your reasoning. It obeys 4 rows. So do you. 1 specification built twice, once from sentences, once from switches.